Cool. Can everyone hear me? I think yes. Hello everyone, my name is Jakub. I'm part of the Cisco Meraki escalations team. And today I'm going to talk about wireless design from the client perspective, right? I think a lot of time when we design networks, we validate, we look at the measured data. It's very easy for us to forget that, Sidekick is very powerful. Client devices are quite small, smaller antennas, different reception, different sensitivity of how we hear the APs. So that's what we will try to cover today. Couple of words about myself, if the clicker works. It does. I'm Jakub. I'm originally from Poland. I've been part of the Meraki team for 10 years, have a Dalmatian, I like fishing. And same as Fere, who presented a couple of presentations before, I'm also part of the Cisco Live NOC team, where I'm responsible for the wireless. So, last year, whoever attended the Wi-Fi Design Day, we covered the love triangle, right? We covered all different relationships that exist in the world of Wi-Fi. Client to AP, AP to client, and AP to AP. Well, this year, I decided to cover the different relationship, which is client to AP. So, we have two kinds of relationships that we can distinguish. Uplink, right, so whenever client transmits to an AP, and the downlink, whenever AP transmits back to the client. So, over the next 18 minutes that I have left, we will do a lot of definitions. First of all, we'll define what client devices do. Then we will look at some of the trends and client behaviors that we observed at the most recent Cisco Live event that we hosted 2 months ago in Amsterdam. And I'm going to be sharing some of the tips and tricks that you should keep in mind when designing for those client devices. So, before we get anywhere, we need to define what client is actually responsible for. What is it doing in your network? It's responsible for 5 functions, right? First of all, it needs to select an AP it wants to connect with, right? It always selects the one that's the strongest, the most powerful one, whatever is the chipset logic that's implemented. The second thing it has to do, it has to associate and authenticate. Once all of this is done and is happily connected, it has an IP address, it has to select an uplink data rate for the transmissions, right? And this is when a lot of problems can happen when you have asymmetry when it comes to transmit powers between clients and the APs. And then the 2 last ones were roaming decisions and random disconnects, which are the 2 favorite ones because this is usually when I get to work with some of you. So let's visualize it, right? A client has to select an AP. So what elements does it use to distinguish that APA is better than APB? Well, RSSI is the most obvious one, right? I'm going to look at how well I can hear an AP. If an AP is screaming at maximum TX power and permitted EIRP for that region, well, it's going to select this one. Then some of the more sophisticated clients go as far as selecting the band, right? I would prefer 5 over 2.4. I would prefer 6 over 5, right? Same for channel width. That also became one of the deciding factors. If you have 2 networks in the same area, one broadcasting at 40 megahertz channel width, another one broadcasting at 20, the 40 will always be prioritized. Some also prioritize a more advanced security methods over, open SSIDs. And there's also some clients that do take care about the QBSS load element that's transmitted in the beacons. So what is the utilization of the given channel and how many clients is the AP serving, right? Once it's happy with the selection, it will then try to associate and authenticate. During that process, it checks all the compatibility. Do we support the same standards? Maybe I don't do 11R, maybe I'm never going to connect to that SSID, right? Once all that happens, they derive the keys, they do the handshake. The last things for the clients to do is get an IP, do all the wired tests, ARP, DNS, DHCP, and off they go. Client devices have a lot of characteristics that we have to keep in mind. So, what defines a client? It's the least powerful device in your network, right? It doesn't see as much as the AP. So, AP can probably hear, let's say, 50 other neighboring APs. If it does hear 50 APs, you probably have bigger problems. The client, not so much, right? So client might hear maybe 3 to 4. It's only aware as to what's happening around it, right? So it may not necessarily know what's happening on the other side of the cell edge. That's why I have like a lot of control traffic to make that communication happen. The power mode on handheld devices may dictate its mode of operations, and we have a slide on that to show you exactly what I mean. Another thing is client devices are not as customizable, right? On the AP, you can change the transmit power. On the client device, you cannot, right? You basically go with what you get. I work for the vendor, and vendor documents are hit and miss, right? Some vendors do amazing documentation, some don't. But if you're working with Apple, for example, they tell you exactly what are the roaming thresholds, what is the AP candidate it will use, what it prioritizes to select an AP. So based out of the data from the vendor, we can do a very nice design. And last thing that the client does, it decides when to roam, because roaming is a client device decision. So before we get started with the design, it's always important to understand what are the capabilities of the client devices. If you're dealing with a network that you own, you know that you use MacBooks, you use Lenovo's. If you work in a warehouse, you know what barcode scanners you use, so you can design for them. But what if you design a network for 20,000 people? You don't know what they will bring, so you want to make that network as compatible as possible to onboard as many clients as possible, right? Here's a screenshot from the Meraki dashboard where we provide all the capabilities that a client gives away during association. One thing we do know is that sometimes the clients hide all the capabilities. That's why I have some industry tools like WNPies where you can use features like Profiler to actually see all the capabilities. One common mistake I'm seeing happening out in the field is, let's say you're transitioning to the latest generation access points, you're going with Wi-Fi 6E or Wi-Fi 7 these days, but you still have those 5, 6 SSIDs that you had in your network for the last 10, 15 years to support those legacy clients. What businesses tend to do is they tend to stick with that very legacy SSID configured in a very legacy way that prevents the latest and greatest devices like iOS, MacBooks that do Wi-Fi 7 or Wi-Fi 6E to suffer because they prioritize the legacy clients over performance of the latest ones. So, mode of operations. Here's an example of an iOS device. When it goes to low power mode, it suddenly starts to use one by one, right? So the throughput goes down. Again, going down from 1.6 gig of throughput to 900 meg is not that terrible, but operations do differ, right? Then next thing we need to do once we have all the capabilities of the client is we need to try to look at the network from the perspective of the client. We need to look at the network through the client's eye, right? One thing that's very common is, we try to set the TX power way too high on the APs. Basically, it causes a massive imbalance, right? And you will end up with asymmetric performance, whether it's uplink or downlink. How we can tune it? We can't really do much on the client, right? There's not option to go in and be like, I want to use 6 decibels, I want to use 12. No, so we have to do that from the AP perspective. Setting a power too low on the AP can lead to a couple of problems. It can lead to aggressive roaming, but sometimes roaming is desired. But also in a busy environment, and also depending on the height of the antenna, there can be very aggressive rate shifts, right? Basically, a slight movement of a laptop or a handheld device of a couple of centimeters provides a significant decrease in RSSI, and then suddenly client may panic, do some weird rate shifting. On another side, if we go too high on the AP, it can lead to other problems like sticky clients, that can lead to oversubscribed APs, and basically you're out of spectrum and everyone's not having a good time. So to put that into perspective, this is then AP when I was doing a design for Cisco Live with Wi-Fi 7. If I use a cell edge of -64, why? Because that would be cell edge of -70 for iPhones. I know, Jakub, why are you offsetting a predictive design? Because I know how devices operate in that environment, so I like to have the flexibility of doing that. At 13 dB TX power, we have the cell edge at 80 meters, so it's quite wide. At 5 decibels, the cell edge is at 40 meters, so it's much smaller, but the biggest difference between the two, the spacing between the lines shows you a 3 decibel loss, right? So basically, the moment you use a higher transmit power, you can move around, a couple of centimeters, even meters, and the RSSI will be kind of static. Well, it won't be as a sudden drop from the client perspective, right? Whilst when using the 5 dB, a slight movement can be 2 decibels, 3 decibels, 6 decibels lost, right? And devices may start panicking. So what's the best secret sauce for those kind of deployments? Well, a sweet spot, I think, would be somewhere in the middle. Again, it's subject to height. 5 dB will probably work if the Omni was installed like 3-4 meters above the ground. We're installing APs at approximately 2.2, 2.4 meters at the venue. So anywhere between 8 and 11 would be acceptable. Yes, the cell will be much bigger. The clients might be sticky. That's why then we should use higher data rates. That also overrides the sensitivity of the AP. And then we can do final fine-tuning with RxSOP. So let's now delve into how do we actually design a network for 18,000 devices. There are multiple elements to keep in mind. Cisco Live for us begins in December, where we as a core team meet for a week and do all the brainstorming. We start with SSIDs. How many do we want? How many do we need? Can we consolidate some of them? Then we go into the security, right? Yeah, we want to keep everything secure. We want to make sure we use the latest standards. But if you go too heavy on security, then ease of onboarding becomes a challenge, right? We don't want to build a very secure network that no one is able to connect to, so we need to keep a good balance to onboard as many customers as we can. Then we look into the coverage. The venue that we use in Amsterdam, it has an existing install of 700 APs, and the coverage is there. The question is actually about capacity. Do we have enough capacity? Because Cisco Live is an event same as this one. Everyone is in the tech industry. First thing you guys do, connect to the Wi-Fi, do the speed test, right? And why is it so slow? And last thing we discuss is, do we do anything cool this year? Do we want to experiment with Wi-Fi 7? Do we want to deploy more of 6 gigahertz and more latest and greatest? So that was our strategy for the SSIDs for this year. We did 5 and 6, 5 on the legacy one. We'll go back to that. Those SSIDs allowed us to onboard 15 to 16,000 clients, right? So again, this graph doesn't show us the clients throughout the entire event. It was just a snapshot throughout the 5-minute time frame, right? So we see we're able to onboard 15,000 clients, no problems. No one came to us that they're unable to connect. So let's try to break them down a little bit. How did we onboard all these clients? Well, we didn't do any of these. The moment you do any of these, you basically discourage customers and clients to connect. They'll continue to use 4G, and they can probably get by. What we do instead is we print the pre-shared key at the back of the badge, right? So you have options for the main production SSID Cisco Live with the bank. We have a legacy option, right, for the least capable devices. And we also do open roaming, right? So anyone using Cisco Events app, they can automatically connect as we push the profile with certificates to the mobile devices. Why is it important? Providing secure and easy access is key. Why? Because if clients do not connect to the Wi-Fi, they will end up wasting a lot of airtime, right? So suddenly you will see all of these probe requests for coffee Wi-Fi, airport Wi-Fi, guest Wi-Fi, any location they've been to before they came to your venue. They're wasting, precious resource called airtime. Things can get ugly very quickly, right? Because I only showed you clients probing for the specific SSID name. What if they broadcast? What if they're asking for all of the SSIDs available? Well, you can end up with this, where basically 5 gigahertz is full of control frames, management frames, probe responses. It's not usable for data traffic. So priority number 1, get clients to connect, make it easy for them to connect. Did you notice something about the SSID configuration also? So yeah, we have a few of them, but we also went fully ballistic on WPA3. So last year we had WPA2 on the main SSID and WPA3 here and there. This year we decided we're going to be brave and we see how clients actually connect, right? Because there's a perception that, oh, WPA3 is this new standard, we're afraid our clients are not ready. Well, we tested it for you, we onboarded 15,000 clients. The WPA2 SSID that we had for legacy, it was mainly used because it was also the SSID where we provided IPv4, and most of the customers connecting to that SSID used it because they had some custom tunneling technologies that only used IPv4. But two main reasons for WPA3. Well, WPA3 is more secure than WPA2. What about compatibility? No longer a problem. I think the numbers speak for themselves. But also 6 gigahertz. Last year, we had a couple of areas deployed with 5 and 6 gigahertz. 1,000 of 6 gigahertz capable clients never connected to 6 gig because customers, users never realized they actually have to be on WPA3 SSID to use 6 gigahertz. Airtime is the most precious resource, and we followed a very advanced formula to justify it. The more clients you get on 6 gigahertz, the less clients you get on 5, right? So you're basically making Spectrum a better place for more. So this is the snapshot from the same physical place where we were about to deploy 6 gigahertz. 5 gig is busy, 6 gig is empty, right? So yet another reason why we want to use that 6 gig in public venues. So going back to that snapshot, at that point of time, we saw 1,000 active clients on 6 gig. And you may wonder, so you're telling me the adoption is only 10%? Kind of. Let me explain. So we only had 120 Wi-Fi 6E and Wi-Fi 7 APs deployed around the area, right? So adoption was quite good, but now if we look at the entire venue, it's quite big actually. The areas that highlighted in orange, this is where we did full 6 gig coverage, right? So this is when we arrived a week before, we deployed our own kit, configured everything, disabled what's overhead, you had 5 and 6. We also have some areas where we are concerned with capacity requirements. So historically what we used to do is in those areas that I call danger zones, where we have like little theaters, we would install the 2533s, or commonly called trouts, right, to provide more capacity in those areas. This year we decided to go crazy, some would say, and we did infills with 6 gigahertz to see how it will behave. So in the areas where we had 5 and 6 full coverage, 40% of clients were constantly using 6 gigahertz, right? So that shows that the adoption amongst the client devices is actually quite good, right? What about the areas where we did the infills? And why would we do that? Well, apparently a lot of people would like to see Matt present about Ekahau AI Pro. I was surprised also. But exactly that. This area would probably be covered by 2 overhead Gilaroos, right, at approximately 20-25 meters height. Again, coverage was there, capacity wouldn't be, right, because those antennas are quite directional. Some of those users would stand in the shadows, right? They would never get a nice coverage. That's why we deploy them. So in a 5 gig mostly areas, where we deployed up to 5 and 6 units, right? We used 9166 D1s. We saw the same trend. We saw that 40% of clients were actually connecting to 6 gigahertz. So that was quite amazing that we were able to offload as many clients out of the busy 5 gig spectrum. We did also a lot of roaming tests, right, to see how the clients would behave roaming between 6 and 5, 5 and 6. They roamed without any problems, not even a packet loss. So how did we achieve that 40 to 60 split? By careful RF design. So the main priority for me when designing the venue was to keep the 5 gigahertz cell and 6 gigahertz cell exactly the same, right? So, you know, the antenna gains between the flex radio, primary radio will be different, so that had to be taken into account. I know there's an ongoing conversation, okay, what about the penetration of 6 gigahertz? Is it that bad? Well, we've actually seen that it's almost identical to 5. We've also seen in some areas it was much better than 5 gigahertz, right? But, you know, for that area over here was all Wi-Fi 7 also. So another priority was that for things like MLO, we wanted to keep 5 and 6 look exactly the same. Another thing is we keep the config in place being exactly the same. So we've noticed on the first days when, you know, everything went in, and between the controller guys did their magic and assigned all the tags, some of the 6 gig radios were using 40 megahertz channel widths. My client would never roam back to 5. It will never consider using 5, right? So I would be stuck at minus 85, minus 90, just because it believed it's good at 6 gigahertz, 40 megahertz. The moment we did 20 megahertz everywhere across 5 and 6, we were happy. But Jakub, what about the 10% adoption? So I work from Meraki where we do have access to a lot of data and we can analyze the trends. So a couple of months ago, we've decided to look into the adoption of 6 gigahertz, right? So we have over 500,000 of online Wi-Fi 6E devices online as we speak. Only 37% of them have 6 gigahertz enabled in their RF profile, right? So again, not bad. We're seeing 40% of clients adopting 6 gigahertz on a venue, so 40% adoption amongst the businesses. Not so bad. But what is another requirement to actually have 6 gigahertz broadcast? Is WPA free? Someone wants to guess how many of them actually broadcast on 6 gig? 5%. Almost 10. So only 10% are actually using 6 gigahertz amongst all these APs. So we actually had an interesting conversation with one of the customers not that long ago, where they had issues on 5 gigahertz, and we told them, hey, you can go 6 gig. You have APs that are 6 gig, but you use them in 5 gig mode only. And they said, nah, we're not ready, just don't even bother, fix 5 gig for us. So I believe that data-driven way is the only way, and the moment we can put something on paper and show the stats from the network, it's a different discussion. So that network, 100 plus APs using capable of 6 gigahertz running in single 5 gig mode, over 1,000 corporate devices connected over the week, 70% of them 6 gigahertz capable, 98% of them WPA3 capable, right? Because WPA3 is mandated by the 11AX certification. So, those numbers speak for themselves. Basically, we built a bulletproof case study for them to actually switch on the 6 gigahertz. Wi-Fi generation, Wi-Fi 6 was the most popular one. From Wi-Fi 7, we saw approximately 200 clients throughout the event, so not great, not terrible. Maybe next year we'll see more. But if we look at the client devices, of course, Apple was the most popular one, right? iPhone was the most popular of the devices that we have seen throughout the event, followed by iPads, MacBooks. So if you were to design a network for the client, the most compatible client, if you design for an iPhone, you're probably going to get it 9 out of 10 times right. iPhone 7 was the lowest generation that we have seen. The good thing about iPhone 7 is that this is the oldest iPhone that already supports WPA3, so that gives us more confidence that the WPA3 is no longer a problem. There's another good reason why it's good to have Apple as one of the most popular client devices. Their documentation is amazing. They tell you exactly what is the selection process. They tell you exactly when they roam. They tell you exactly when they look for a better AP, right? So if you haven't checked out those documents, please do. They're amazing. And to bring up an example of such a document, this is what they give you, right? I'm not going to read this out loud, but basically they tell you that the roaming threshold for an iPhone is anywhere between -70 and -75. It all depends whether the client is actively transmitting data. And then if the client is transmitting data, it will look for a candidate that's 8 decibels stronger. If it's idle, it's going to look for a candidate that's 12 decibels stronger. So you can easily apply that into your site survey tool or planner, right? And look for primary coverage at -70 to have secondary coverage at -62, and you're done, right? They also outline that they prioritize Wi-Fi 7 over Wi-Fi 6, Wi-Fi 6 over 5, 5 over 4, and the same applies to channel widths, right? So all the testing we have done during Cisco Live kind of proved us right. So main takeaways, client perspective is different to the AP and site survey, so make sure you always adjust whatever you look at. Keep that in back of your heads, right? Because you're not designing for sidekicks, you're designing for mobile devices. You want your clients to be happy. Never sacrifice the performance of 80% of new, more capable clients over the 5% of like 11N clients, right? I think you're better off to have an extra SSID that's just for legacy over everyone else, over everything else. Make onboarding as simple as possible. Make the most out of 6 gig, and do not be afraid of WPA3. Thank you so much.